Okay, can you see my
Yep.
screen? Perfect. Okay. Yeah, so the good thing is, people, we've already talked through the need for linkage, the need for connected data sets, and then where we're sort of Helen ended with, we need privacy to kind of make sure that we promote our societal values and purposes. I think that's kind of where I want to start, right? Is I'm not going to talk through, when we think about sort of ethical concerns and issues in record linkage, there are a lot of them, and I can't do them justice in the short amount of time I have. So I'm going to focus on kind of one specific piece, which is bias in linked data sets. What does that mean? Where does that come from? And most importantly, how do we deal with it downstream when we're using it in different circumstances for different purposes, right? And the two purposes I'm thinking about, one is, and we've mentioned both during the day. We've focused a lot more on measuring the value of science, but the other one I want to make sure we focus on too for these things is actually increasing the value, right? So how do we improve? How do we allocate resources? How do we figure out where to put additional resources to increase the value? And linked data sets are useful for both, right? They're useful for evaluating and showing impact, but also useful for directing and allocating additional resources. And biased linked data sets, obviously hurt that, right? So what I want to sort of talk through a little bit is, where do these biases come from in these linked data sets? Because unfortunately, most linked data sets don't really come with a set of biases in there, right? We often get the data set, and then a lot of downstream users will take that as ground truth and start using it. And I think that's risky, because we're not informed about the issues, where it's coming from, and what do we do about it, right? So if we kind of start with where do these biases come from? Well, the first point is really from the source data, right? Where the source data has it has data quality issues, but if we think about those data quality issues, they might be disparate issues across different groups, right? So when we think about kind of the obvious data quality metrics around, coverage issues in a data set, or accuracy issues, all the error frameworks, or timeliness issues, they're never or rarely uniformly random, right? They're disproportionately impact certain groups. So recently we've been doing a lot of work around unemployment, and if you sort of think about, a lot of government agencies are using unemployment insurance data as a representative of the unemployed population. And of course, we know that's not true, but you have sort of coverage issues there, or even accuracy issues in certain cases, or there have been lots of lags in processing unemployment claims, and that leads to sort of the source data having issues. When the linkage then happens, as Jeff was sort of mentioning, like, it's not as much work has been going on for decades in record linkage. It's still not sort of an off-the-shelf thing that you can just use. You still have to kind of think about your context. You have to customize. You have to tune it to the specific. You're looking at products. You're looking at publications. You're looking at researchers. You're looking at universities. But those methods, as we all are familiar with, make mistakes, right? The type 1, type 2 errors. They either mislink people who shouldn't be linked together, or mislink records, or they miss them, right? And again, a lot of the times when we measure a performance of a record linkage system, we'll have those error rates, or we'll say that the false positive rate, the false linkage rate was X%, and the miss rate was Y%. And we sort of decide which one to pick. But if those linkages, we also know that those linkages the linkage errors are not uniform across different groups. So if you look at, people whose last name changes over their lifetime are more likely to get missed, right? Who does that impact? People who might have changed their name because they came to the US and it was easier for Americans to, pronounce their name. So they decided to change their name. Well, so there are lots and lots of those. If you actually look at a lot of these, every time I've done a linkage project, when we actually break down the errors by gender, by race, by background, it turns out that they're not uniformly random, which means that downstream, when we do inferences or actions based on that linked data, we disproportionately impact the people that we had disparate errors on in our linkage method, right? And this is not limited to linkage, right? This happens pretty much in any problem where we're using, statistical machine learning and all of those buzzword tools to do any type of analysis. All those analyses have the same problem. We have these errors. Those errors are typically not uniformly random across different groups. And those disparate errors lead to equity issues downstream, right? And so the question is, what can we do about it, right? I think, so we often sort of use sort of this larger framework for these types of things. Is there are too many biases to think about, right? So how do we figure out which bias do we really care about? How do we measure it? How do we understand where it's coming from? How do we try to improve the method as much as we can, but eventually it's still not going to be perfect. So how do we mitigate the impact downstream of using that linked data set on equity issues? And then how do we continue to monitor and evaluate? Because these are not one-off analyses that are happening. These are continuous, more and more, they're not, the data is getting refreshed continuously. So your linkage is happening continuously on the fly. And that leads to other issues that I'm not going to go into, but a lot of the old days, you had data sets that you would link, and now you're doing this on the fly linkage as you're getting new records at the same time. So the first step here is what bias metrics do we really care about? And this is a broader framework that we've developed for more around policy areas if you have too many metrics. So let's focus on the ones that matter. So in this doesn't directly apply to record linkage, but think of it as, if you're intervening on using these types of tools, if you're going to do punitive interventions, horrible things like predictive policing, then disproportionate, false positives are much worse, right? But if you're trying to help people and provide them assistance programs, SNAP and TANF and other types of, then disparate false negatives, missing people disproportionately hurts them much more, right? So thinking about in the context of how this linked data set is going to be used to evaluate the impact of a specific policy or funding decision or program. Is it going to be used to design new programs? Thinking about what metrics would you prioritize beyond the overall, false positive, false negative rate with specific groups? What groups do you care about? Is it certain geographical regions? Is it gender? Is it race? Is it research area? Type of things that Jonathan was talking about. So we've got some tools that can allow you to sort of measure these types of biases by group, open source tools. I'm not going to go into that too much. And then, all of this applies to what we're talking about, because again, historically, we've had sort of these large data sets that are a little bit, they're not completely standardized, but they're a little bit more standardized than the average data set we've got. But more and more, we're accumulating administrative data from different places. And if, Paul Romer had his way, Facebook and Google would dump their data into this, and then it becomes a total disaster for linkage efforts, right? So things are going to change a lot. And so we have to be very careful about linking them while keeping in mind that it's going to produce those types of biases, right? So,
Rayid,
okay, yeah. I'm 30 seconds away. So basically, the three things we want to be able to do is determine what types of biases are important for a given use of a data set. We should try to reduce the bias when doing the record linkage. And then we should kind of develop methods dealing with sort of, once we've linked it, it's still going to be biased. So how do we mitigate the impact? And so the takeaway in my mind is, one is we shouldn't treat these methods as plug and play modules that you just use. Linked data sets shouldn't just be put out as they are. They should be put out with metadata that allows downstream users to decide to kind of figure out how to deal with these bias issues. And we should be really careful about thinking through disparate errors rather than kind of overall errors with these methods, because as when we're comparing them and we're selecting them and we're doing evaluations, because the downstream impact can be, especially for small groups, as we've been talking about all morning. So that's all I have. Thanks.